All right, today we're doing the Unit 1 study guide over factors and multiples. Okay, who would like to raise their hand and tell me what a factor is? Emlet.
Factors are the numbers that multiply together to form a product.
Okay, the numbers that multiply together to get a product. All right, good. Okay, and you can put your tally mark on your paper. Angel, what's a multiple?
A multiple is a number found by multiplying a number by 1, 2, 3, and so on.
Okay, so a number, so to read it to me one more time, Angel.
A multiple is a number found by multiplying a number by 1, 2, 3, and so on.
Okay, a number found by multiplying a number by 1, 2, 3, ... What should I put in parentheses under multiple? Ansley? Yes, skip counting. Exactly. So multiples are found by skip counting. All right, good. All right, so Ansley and Angel, you can put yourself down for a point as well. All right, here we go. Number 1 says, is 27 a prime number or a composite number? Explain or show your reasoning. So how many factors do prime numbers have? Lucius?
1. Wait, 2.
2, exactly 2. 1 and itself, right? So prime have exactly 2 factors. 1 and itself. Okay? What about composite numbers? How many factors do composite numbers have? Kennedy?
3.
3 or
More.
3 or more, yes. Okay? 3 or more factors. Okay. So, 27. We've got to figure out whether 27 is prime or composite. So let's start by listing the factors of 27. So for 27, what are we going to start with? Bella?
1 times 27.
You got it. Put yourself down for a point. If you guys are answering a question correctly, you'll put yourself down a little tally mark on your paper. Okay. Is 2 a factor of 27? Can you multiply 2 by anything and get 27? Yes or no?
No.
No. So if we're skip counting by 2, all of our numbers are even, right? And 27 is odd. Okay? So if we go to the 3 row on our multiplication table, is there a 27 there?
Yes.
What's 3's partner?
9.
9. So our next factor pair is 3 times 9. Now we have the biggest the smallest and the biggest. Then we've got 3 and 9. So now we've got to check the numbers between 3 and 9. So we've got to check 4, 5, 6, 7, 8. We're not going to check 9 because it's already up here. So if we check the 4 row, is there a 27?
No.
No. 5 row?
No.
6 row?
No.
7 row?
No.
8 row?
No.
So we know we're done. So how many factors does 27 have? Show me on your fingers.
Oh,
Should be holding up 4 fingers because 1, 2, 3, 4. Now, if I said how many factor pairs, there would be 2, right? But if you think about pairs of shoes, if I have 2 pairs of shoes, how many actual shoes are in front of me? 1, 2, 3, 4, right? So there's 4 factors. So this is what I want you to write down on number 1. Let's do a custom color. Let's do, okay. All right, so 27, you need to write 1 times 27 and 3 times 9. And then, so 27 has 4 factors. So is it prime or composite? Composite has, since it's got 4 factors, is that the 3 or more? Yes. So we're gonna write, also write 27 is composite. Because it has 3 or more factors. And that's the rule for composite. Okay. Okay, next we're gonna check on 29. And if you guys don't finish copying all this down, and we go on to the next one, don't worry. I can put it up at the end, okay? If we go on to the next one, it says, is 29 prime or composite? Explain or show how you know. So we start with 1 times 29. Is 29 even or odd? Odd. So is 2 a factor of 29? No. So if we go to our multiplication table, is there a 29 on the 3 row?
No.
4 row?
No.
5 row?
No.
6 row?
No.
7 row?
No.
8 row?
No.
9 row?
No.
No. So that means how many factors are there in 29? Show me on your fingers. 2. 1 and 29. 1 in itself, which means it is prime. So here's what I want you to write down. 29 is 1 times 29, and 29 is prime. Because it has exactly 2 factors. On the next one, it says select all the true statements. So that means just circle them if they're true. So these are easy to get mixed up on because so it says 15 is a multiple of 3. So I would like for you to underline the words multiple of 3. So what do we do when we're finding a multiple of 3? Skip count by 3. So if we're skip counting by 3, we're going to do that over here. 3, 6, 9, 12, 15. So is 15 on our list? So is 15 a multiple of 3? Yes. So we're going to circle A. You with me, Quentin? Making sense? Awesome. All right, so write your 3, 6, 9, 12, 15. There you go. All right. Next, it says, is 16 a factor of 8? So when we're finding factors of a number, we're just gonna come over here and let's list the factors of 8. So what do we start with, Isabella? What are the first 2 factors of 8? What were the first 2 factors of 27? First 2 factors of 29? What are the first 2 factors of 8? Ella? No, we're finding factors of 8. So that I'm glad you said that, because that is that's what a lot of students do. They're like seeing 16 and factors, and so they start listing the factors of 16. But right here at the end, what number is right after the word factor? 8. So we're looking for factors of 8. So what are the first 2 factors of 8, Ella? There you go. 1 times 8. And then, Grady, what are the next 2 factors of 8? So we've got 1 times 8.
My multiplication table.
You can grab it out. Emlyn?
2 times 8.
No. Jesse?
2 times 4.
2 times 4. Okay. So 2 times 4. Does that make sense? Okay. All right. So now that's all of them, right? That's all the numbers you can multiply together to get 8. So is 16 on that list? Nope. So is 16 a factor of 8? No. It is a multiple of 8, but that's not what the question says. So the next one says, is 80 a multiple of 4? Now our multiplication tables don't go up to 80, but we can use a little bit of reasoning. So 4 times what gives you 8? What do you multiply 4 times to get 8? Riley? 2. Now what's the difference between 8 and 80? And 80 has a what at the end? 0. So watch what I'm going to do, guys. This is cool. If I add a 0 on this side of the equal sign, what do I have to do over here? Same thing. Add a 0. So if you count by 20s, 20, 40, 60, 80. So is 80 a multiple of 4? Yes. Because if we count by 4s 20 times, we're going to get 80. So we're going to circle C, and this is what I want you to write. 4 times 20 equals 80. All right. The next one says the only factor pair of 49 is 1 and 49. On your multiplication table, do you see another 49 on there? Look at your multiplication table. Is there any other numbers that multiply together to get 49? Ivan? You're right. So this can't be true, right? Because Ivan just found that 7 times 7 also equals 49. But D says the only factor pair of 49 is 1 and 49. So D is wrong. Okay, and the last one on this page says, oh no, the last question on this problem says, the factor pairs of 12 are 1 and 12, 2 and 6, 3 and 4. So if we list the factors of 12, 1 and 12, 2 and 6, 3 and 4. Is that all of them? All the ways you can make 12. So we started with 1, then we went to 2, then we went to 3. We don't have to look for 4, so we're done. Remember, if we think of this as a number line, and we start with 1 and end with 12, they're partners. Then we do 2 and 6 are partners. And then 3 and 4 are partners. So we're done. Okay? So that is true. So make sure you circle E. All right. I really wish they had put a smaller number for the very first test than 84, but we're gonna go through this together. Okay. And we're gonna use a little reasoning here. Okay, what are the first 2 factors of 84? Addie. 1 times 84, that's correct. Okay. Now, think about 84 for a second. Can you multiply 2 times anything and get 84? Jack?
42.
Nice job, buddy. I wasn't even on to that yet. You're exactly right. How'd you figure that out, Jack? Did you cut 8 in half and then 4 in half? Very good. Yes, 84 is an even number. That means that all even numbers can be split evenly by 2. So this one works out really good because both of the digits in it are even. So you can just say what's half of 8? 4. What's half of 4? 2. All right, I'm gonna tell you a little trick and you're not gonna have to know this for the test, but you know how we look at 84 and we say, I know that 2 is a factor because 84 is even, right? There's a way, a little secret trick for 3s. And the little secret trick is, if you add the digits of the number together and your answer is a multiple of 3, then the original number is a multiple of 3. This is what I mean. What is 8 plus 4? Ansley? 8 plus 4.
I had it.
Figure it out real quick. You got it. Use your fingers.
8 plus 4.
Uh-huh.
12.
Yes, it is 12. So since 8 plus 4 is 12, let's come over here. Is there a 12 on the 3 row?
Yes.
Yes. That means if we kept going on our 3 row, eventually we would count 84. So that's a little trick. So 3 is a factor, but I don't know what its partner is yet. We'll come back to that. Okay. What about 4? What's 8 divided by 4? Jack?
2.
2. What is 4 divided by 4? Kennedy? Not times. 4 divided by 4. 4 cookies, 4 friends. How many cookies does each friend get? 1. All right, so that means that 4 groups of 21 add up to be 84. 1 plus 1 plus 1 plus 1 is 4. 2, 4, 6, 8. 84. Okay? So then, 5 is not a factor of 84 because factors of, or multiples of 5 have a 0 or 5 in the ones place. So 5 is out. Go to your 6th row. Is there an 84 on it?
Oh.
Go look at your 6th row. Quentin, do you see an 84 on there?
Yes.
What is 6's partner to get to 84? Nice job. Yes, 6 times 14. We'll put your tally mark down on your paper. Okay, go to your 7 row. Is there an 84? Grady, what's its partner?
14.
No?
12.
12. There you go. All right, 7 times 12. So now we just need to check 8 and 9. Is there an 84 on the 8 row?
No.
Nope. Is there an 84 on the 9 row? Nope. Okay. Now we got to come back and find out what number goes with 3. So I know it's going to be bigger than 21, but smaller than 42. So what number do you want to try? 3 groups of this number equals 84. Jack, what do you think? Let's just try 30. So if we do 3 groups of 30, 30 plus 30 plus 30, what does that equal? 90. So 30 is a little bit too big, because we ended up at 90 and we want to get to 84. So what's a number that's smaller than 30, but just a little? Isabella?
20.
20. So if we do 20, it would be 20, 20, and 20. That's only 60, so it's bigger than 20. Ella?
28.
Let's try 28. So if we do 28, 28, 28. What is 8 times 3? Ansley? 8 times 3.
24.
You got it, girl. Put down the 4, carry the 2, then we have 2, 4, 6, 8. 84, that's what we were going for, so 3 times 28. So here's what you're gonna write down. All right, the one on the test is a lot smaller than this. It's smaller than 84. I think that's big. Okay, 1 times 84, put it down. 2 times 42, put it down. 3 times 28, put it down. 4 times 21, 6 times 14, and 7 times 12. That's all of them. Okay, and they're all right here in red if you still need them. All right, last page. Pon is playing a card game with friends. The number of cards never changes, but the number of players does. With 5 players, the cards can be divided equally between the players. Could there be 50 cards? So I want you guys, you can kind of draw it out if you want. I want you to think this through. So if we have 5 players, 1, 2, 3, 4, 5. Could there be 50 cards? And all of them would get the same amount. Emily?
Yes.
How many cards would they each get? 10. Nice job, yes. So let's count. If they had each got 10, 10 for you, 10 for you, 10 for you, 10 for you, and 10 for you. That's 10, 20, 30, 40, 50. So there could be 50 cards with 5 players. So here's what we're going to write down. Could there be 50 cards? Yes. Because 50 divided by 5 equals 10. 50 is a multiple of 5. Okay. The next one says, if only 3 players are playing this time, and they all get the same amount of cards, could there be 50 cards? So in other words, if we're skip counting by 3s, would we eventually say 50? Nope, because do you remember a second ago I showed you the trick for 3s? What's 5 plus 0? 5 plus, not times, 5 plus 0. So you have 5 cookies, I give you 0, you still have 5 cookies. Is there a 5 on the 3 row? No, that means if we kept going, there would not be a 50. You with me?
Yeah.
So here's what we're gonna do. Could there be 50 cards? No, because 50 is not a multiple of 3. Emily? not a multiple of 3. All right, the last question says, with 4 players, the cards can be divided equally between the players. How many cards could there be? All right, so now we know that 3 cards, they could divide evenly. 4 cards, they could divide evenly. And 3 players, they could divide the cards evenly. 4 players, they could divide them evenly. 5 players, they could divide them evenly. So what we're really looking for here is a common multiple. So we're going to skip count by 3, 4, and 5 and look for a number that appears in all those lists. Okay, you ready? All right. So let's start with 5. Okay, count with me. Skip counting. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. Stop there. 45, 50, 55, 60. Okay. Now, let's skip count by 4s. 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48, 52, 56, 60. All right, let's stop there. Okay, and then 3s. Holly, you need, just scoot under there and get it. Okay, 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39, 42, 45, 48, 51, 54, 57, 60. Okay. Now, I want you to look at those lists and find a number that shows up in all 3 lists. Quentin, what is it? 60. That's why we kept going. 60 is the first one, I believe. Okay? So, and the reason that 60 works, so there are 60 cards in this game. The reason 60 works, and if you don't want to go through all of that, all you have to do is multiply 3 times 4 times 5. So what's 3 times 4? 12. And 12 times 5? Look at your multiplication table. What's 12 times 5? 60. So, here's what we're going to write down. With 4 players, the cards can be divided equally between the players. How many cards could there be? Here's what we're going to write down first. Any multiple of 4. Let's see. Hang on one second. Any multiple of 4, but it would also need to be a multiple of 3 and 5. And then we're going to write 3 times 4 times 5 equals 60. There are 60 cards. For this last one, what I just want you to remember on the test is that you'll just need to multiply the number of players together. this.